Okay, hello. Um, yeah, so we're working on surds. Surds refer to numbers that surds refer to numbers surds refers to numbers that are like roots of numbers that don't have roots basically. So like the square root of 9 is not a surd because the root of 9 is 3. But the square root of say 7 doesn't have a square root, right? So it's a surd. So a surd is a number that cannot be simplified any further to remove the root. It could be a square root or a cube root, and it doesn't give a rational number. Is also called a radical. So basically, square root of x or square root of any number that cannot be simplified. Um, then we also have what we call imaginary numbers. Imaginary numbers are numbers that are square roots of negative numbers. Maybe square root of -7 or square root of -20 or square root of -9 or square root of negative anything, right? Because basically, in the space where we have real numbers, there is no solution. So we came up with the idea of imaginary numbers because it allows us to work with them without actually acknowledging them, as real numbers. So they're imaginary numbers. So here we have determine whether the following are surds, rational numbers, or imaginary numbers. Um, so is this a surd? This is a surd, right? Yes, this is a surd because 300 doesn't have a square root. Okay. This here is an imaginary number. It's imaginary because -400, even though 400 has a square root, but like it's negative, so square root of a negative number, doesn't give you a real solution. It gives you an imaginary solution. Square root of -9 is 3, so this is a rational number. I feel like somebody's saying, but he didn't tell us what rational numbers are. Well, a rational number is a number that can be written as a fraction. Rational means fraction, right? So like 3 over 1, anything. But the better way to think about them, you can think about them as um, predictable decimals or decimals with an end. So say 1 over 4, for instance, is 0.25. So it's rational. Yeah. 3 over 7, even though this wouldn't give you, like this would give you a decimal that has no end, you can punch it in your calculator, but it's going to be repeating at some point, right? Because it can be written as a fraction. Some of them might also have no end, but there's like a pattern, like 0.99999, 0.8, 0.222, something like that. But when you say irrational numbers like surds, if we try to get the square root of maybe 10, all right, you will get a number that has no pattern, and so it doesn't repeat, it just continues forever. It's irrational because it's unpredictable. So other popular irrational numbers are like pi is an irrational number, and even your e. Okay, so square root of 240 is a surd. It doesn't have a direct square root, it's a surd. Okay, so that's it for this. Okay, so we have more practice questions here. This says determine whether the following are surds, rational numbers, or imaginary numbers. So this is a surd. 20 doesn't have a square root. This is imaginary. This is a surd. This is 60, right? Because 60 times 60 is 3600. So this is, a rational. You say this is a rational number. This is a surd. This is 9, so it's rational. This is 16, so it's rational. This is imaginary. Okay, so yeah. Surd index relationship. So we need to learn how surds and your indices, your laws of indices, how they coexist, right? Um, so a fractional power means a root. So if I say x raised to the power of 1 over 2, for instance, that's something as square root of x. Okay. So this rule, as simple as it is, just holds the relationship between surds and index numbers. So say you have 2 raised to the power of 4 over 5. Okay. So you can write this as 2 raised to the power of 1 over 5 raised to the power of 4. Okay, because if you remember your rules of indices, 4 times 5, 4 times 1 over 5 would give you 4 over 5. So you can rewrite this as the fifth root of 2 raised to the power of 4. Okay, so you can write it that way. So sometimes you have some sort problems that you best solve by converting to index, and some index problem or indices problems that you best solve by converting to surds. So you should be able to master them both ways. And it's something you can work on outside of this, because we don't have enough examples here. We're just trying to throw the topic in or remind you of the idea. Okay. So this guy here would be, if I want to rewrite this, I'll rewrite this as, well, this would be x raised to the power of 1 over 3 raised to the power of 5. Then I can multiply the powers to give me x raised to the power of 5 over 3. Okay. So if I'm rewriting this, this would be, well, this guy inside will just be, okay, let me say 49 z squared raised to the power of half. Okay, but then you can spread out that half to have 49 raised to the power of half times z raised to the power of 2 raised to the power of half. So when you spread out the powers, you would have 7, because 49 raised to the power of half, that square root of 49 is 7, 7z, because 2 times half is 1, so 7z basically. This guy here would be, okay, so we can write this as 2 raised to the power of 1 over 3, then raised to the power of 5, which would be the cube root of 2 raised to the power of 5. Okay, and this would be the fourth root of 3 raised to the power of 7. So you can write this way. So being able to go back and forth actually helps, a lot. Helps a lot. All right, so let's look at simplifying surds. Okay, so I'm writing here, if you have maybe square root of 20, for instance, so let's just play around with something simple, right? You can break this down into square root of 4 times square root of 5, right? Because 4 times 5 is 20. And why did I choose these two factors? Because 4 has a square root. So you can rewrite square root of 4 as 2 and then root 5. So root 20 is actually 2 root 5. So this takes a bit of practice. So you have a job of breaking down your surd into factors that have roots, right? They have relevant roots. So for instance, let's say, so now say we have this guy here. Okay. So we have 48x squared. Or root 48x squared. So I can think of all the factors of 48. What are the powers I can get in 48? I can get 3, then 16, then x squared. Okay, because 16 has a square root. So I would have 4 here, and I'll have x here, and I'll have root 3. So you can just write this as 4x root 3. Okay, so that's a simplified form of that. So I broke 48 into its factors, like I used 4 and 16. Again, you could have used, well, you could have started with 4 and then brought out 4 again. You would get the same thing, right? Even if you wanted to break it down 4 and then bring out 4 again, that's fine. But by the time you break it down to the simplest form, you would have this as a solution. For root 20, what do I have for root 20? I have, if I break down 20, okay, yeah, so we'll use 4 and 5, right? 4 and 5. So this would be root 4 times root 5, which would be 2 root 5. All right. For this one, we'll break it down like 120. Well, I can get 4 out of 120, and I think that's the greatest I can get out of 120. 120 divided by 4 gives you 30. Yes, so it's 4. So I'll do, okay, fine. So square root of 4 times square root of 30 times, I'll go square root of p raised to the power of 6. But for r cube, I'll break r cube into r squared times r. Okay, because r squared times r gives you r cube. So you'd have This gives you 2 times, well, root 30 times p cubed times r times root r. So when you combine, everything that is outside and everything that is still inside, you would have 2p cube r, then square root of 30r. So 30r is this guy and this guy. Then the 2p cube r is the combination of this, and that. Okay, what do we have here? We have a lot of examples. For 24, yeah, we can go 4 and 6. Okay, so square root of 4 times square root of 6, that will be 2 root 6. For 24x to the power of 5, you can go square root of 4 times square root of 6 times this guy, you go square root of x raised to the power of 4 times square root of x. Because x raised to the power of 5 doesn't have the square root. You have to have an even power to be able to, divide by 2 when you take the square root. So this would be 2 root 6 times x squared times root x. So you end up with 2x squared root 6x. 2x squared root 6x. Okay, we're nearly done. Square root of 400. So you can go square root of 4 times square root of 100, which gives you 2 times 10, all right, which just gives you 20. So the square root of 400 is 20, right? It's not a surd anymore. All right. For this one, 64, we can go 64 and 10. So that will be square root of 64 times square root of 10, which will give you 8 root 10. Yeah, 8 root 10 is the answer. All right. So that's about it for that. And we have this other set and this other set, and wow. Okay.